Welcome to SolidCAM Professor. I'm Sydney, your SolidCAM Professor, with one of many videos available to you 24 hours a day, 7 days a week. In this recording, we'll demonstrate the use of iMachining 3D on this electronic box. You'll note that in our CAM part, we have our machine defined from our machine database, as well as the material from our material database and the default machining level. Now, if we were to go into our first operation, we just did a regular drilling operation to drill out this hole over here. Just having a quick look at the simulation, you'll see that we have a hole created over there. Now, this hole is important because it can actually help us in iMachining 3D. Now, if we were to go into our first operation of iMachining 3D, is our next operation, you'll note that we have our geometry automatically taken from our target, and also note our working area is automatically marked as cut only the rest material. Now, the rest material in this case includes the fact that the hole was already drilled out. Now, if we go further down, you can see we have our tool of 12 millimeters with a cutting length of 25 millimeters with 6 flutes on the tool. And our levels is up until the bottom of the part over here. In our technology wizard, you'll note that since our tool has 25 millimeters of cutting length and we're only going down 24 millimeters, we can do our large step down in one step, going down to the very bottom that we need over there. And you'll also note that our machining level is at 6, which was our default machining level. Taking a quick look at our technology, you'll see we have our surface and wall offset, as well as our rest rough for stepping up on the parts for the steps that are less than the one step going down, as we'll soon see in our simulation. Let's take a quick look now at the simulation itself, and I'll start off doing this one step at a time. You'll note that since we have our hole here already, the tool will go directly into that hole, utilizing the fact that it can go directly down into the part without having to helical into the part itself. We'll continue now with the simulation, and as you can see, it's doing the step down all the way down to this bottom step over there, and then starts its step up, clearing off these floors over here, as well as the rest of the floors, as we'll soon see, and working only in the areas where it can actually machine. You'll note that it did these steps here as well as its step up, and then went to the outside and cleared the outside as well. Now, our next operation will also be in iMachining 3D, but this time using a smaller tool of 6 millimeters to finish off the areas where this tool, the previous tool, cannot work, such as these corners going into these areas over there. And remember, since we have in our geometry, in our working area, cut only rest material, it will only work in the areas where the previous tool could not work. Taking a quick look at the simulation itself, you'll see that the tool will go down and only work in the corners and the floor areas where that previous tool could not work, as shown over here. Now, to finish the part, we just use a simple HSM operation of combine constant Z together with horizontal machining, as shown over here. If we take a quick look at the simulation of the entire part, you can see that we have our rough cut, as shown over here, going down first to the very bottom over here, and then started stepping up of rest machining of these areas over here, as well as the steps over there and around the part itself. Then finishing off the corners where the previous iMachining cannot work, and our final operation of constant Z combined with horizontal to finish up the walls as well as the floors of the part. For more videos on SolidCAM Professor, please go to our website www.solidcam.com and look for the tab called SolidCAM Professor. Thank you for joining us on SolidCAM Professor. Take care and have a nice day.